Hai portato un altro grande ospite sempre da Stanford?
Sì, diciamo,
raccontacelo.
Volendo introdurrlo dovrei dire mon frère, diciamo, mio fratello, nel senso fratello scientifico. Oussama Khatib è
Eccolo,
probabilmente...
Welcome to Rome.
Bonjour mon cher.
Bonjour Bruno, bonjour tout le monde.
Bonjour.
Oussama è, a mio avviso, la mente più brillante.
Sorry, Oussama, we are talking briefly about you in Italian, then we give you the floor. Just a few seconds.
Oui, oui, oui.
A few notes in Italian. Ok.
Oussama è probabilmente la mente più brillante che abbiamo nel panorama robotico, è un vero e proprio ambasciatore della robotica mondiale e infatti lui sta soffrendo. Io dico sempre questa storiella, lui è di origini siriane e tipicamente è sempre in giro intorno al mondo. Quando sta a Stanford sta su uno stopover di Around the World Ticket, quindi diciamo, in qualche modo sta vivendo questo momento di confinamento a casa in maniera diciamo, molto, molto traumatica rispetto, sicuramente sarebbe stato stasera qui con noi. Oussama ci mostrerà i progressi della tecnologia per quanto riguarda l'interazione tra esseri umani e robot e questa sera c'è una chicca, c'è una primizia, perché Oussama ha lavorato a un progetto di archeologia marina utilizzando un robot umanoide che è stato impiegato per recuperare un vaso prezioso nella baia di Toulon, nel Mediterraneo.
Questo risale... Ocean One.
Ocean One, bene. Ocean One scendeva a una profondità di 100 metri, il vascello si chiama la Lune, quindi letteralmente quasi diciamo, l'ammaraggio sulla Luna potremmo dire. Bene, a Stanford ora stanno sviluppando la versione Ocean 1K, O2K, che in qualche modo richiama anche le iniziali no, di Oussama, e O2K è destinato a raggiungere una profondità di 1000 metri, che qualsiasi palombaro con qualsiasi...
Non ci potrebbe arrivare.
Soprattutto potrebbe arrivare, però poi non potrebbe avere la capacità fisica di manipolare a 1000 metri di profondità.
Bene, Professor Khatib, the floor is yours.
Merci beaucoup, Bruno. Thank you. I think I understood everything you said.
Very good.
So, greetings from Stanford, where it's still daytime, and I'm going to share with you this exciting expedition we had in the Mediterranean and the development that we pursued since. So, La Lune is a vessel of King Louis XIV that actually sunk off the coast of France in November 1664, centuries ago. So this vessel was hidden somewhere by the coast, and finally we found it in 1993, very close to Toulon actually, and it was found, and the problem, it is very deep. It's at 91 meters. So we use suits to take divers all the way to 91 meters. And it's very difficult to do any interaction at that place with a suit like this. So of course, a human can dive 40 meters, but we really need robots to go deeper. So the idea of Ocean One is not only that we are building a robot that can dive deep, there are many robots that can dive deep, but this robot is able to dive and touch and affect the environment. So you can see here in my hands, there is a haptic device that lets me touch what the robot is feeling when the robot is in the water. So here is an example of this idea of haptic interaction. We are doing a painting, and the human is guiding the motion of the robot, and the robot is performing the task. The human is able to touch and feel what is going on. So the idea is not only about underwater archaeology. It's not about dealing with the corals, placing sensors, and collecting samples. There are so many things in the depth of 73% what covers the planet that needs robotics. So we built this robot with my students And this is the simulation. We tested the robot in the pool. We brought this robot to the pool many times, fixing it. And finally, the robot was ready. We put it in a box and we shipped it to the Mediterranean on the André Malraux vessel. This is the vessel of the RASM, which is the Directorate of Archaeology, underwater archaeology in France, from the Ministry of Culture. And here you can see my colleague Michel Lure, who helped deploying the robot at those locations and others. So our idea was, we are taking this robot from 1 meter test in the pool to 100 meters underwater. So we decided to go to 15 meters, where divers can interact with the robot and check the robot abilities, and everything was going well. So we went diving on La Lune. So La Lune here shows, you can see these two cannon that are still standing. And this is an artifact that our archaeologist colleague wanted us to collect. And in this maneuver, unfortunately, the robot got caught between the two cannon. It was very scary. We thought we lost the robot. It was midnight, but this is not any robot. This robot has arms, and using the haptic device, we managed to rescue the robot. In fact, you will see that on the video, but you can see the face of my student, who was really, really scared, and everyone was scared that the robot was caught. But pushing with the hands against the cannon, we were able to rescue the robot. And we went on the mission. We brought the treasure back. So usually you place the treasure in a container. And once you place it in the container, and you can see here, I'm very happy about to place it in the containers. You close the container, and that is the end of the mission, because the container comes on its own to the surface. And then here is the treasure that we brought. This is my colleague, Michel Lure, and my students. Everyone wanted to touch it. The archaeologist was saying, "It's amazing, you didn't break it." And immediately she said, "This is a Catalan vase from 1664, untouched by humans until now." Well, the year after, we went to Santorini for a different expedition on the volcano, the Colombo volcano. But I'm going to share with you our landing on La Lune. And it was a quite amazing experience. And here is the video. The diver was checking everything on the robot, the hand, and certifying the robot is ready to go to 100 meters. You can see the robot.
Ok, let's go. Denis, on y va.
Franck, tu peux donner un coup de main, s'il te plaît?
Là, ça serait bien s'il descendait là. Du marche au 110 maintenant.
Ok, Michel.
It was very scary diving 100 meters.
Maintenant, redresse et reviens au 150.
Regarde.
Oui, tu y es
On
presque.
est en train de revenir sur zone là. Hein.
Tu y es presque.
On arrive gentiment en marche arrière.
Descends 1 mètre.
On y est là.
Pas plus loin, pas plus loin. Revenez pas par là. Stop.
Stop, recule. Oh my god.
Parce que là, il faut qu'il fasse très attention.
Attention, tu tapes le canon. Tape le canon.
60 cm.
Ok, pour les gars.
It was very scary. However, with the arms, we were able to push the robot.
Oui. Le pot est un peu plus sous lui. Hein. Il est devant toi, tu le vois, et il est très léger.
Il a la main dessus.
Oh, in a close.
Yes.
Il a l'objet.
There you go.
Oui, il est sous moi, il a l'objet dans la main. On est en face de la caisse là, Michel, on approche.
Ouais.
Ok, perfect.
Pas mal. Pas mal. Non, il n'y est pas encore, il n'a pas posé.
Il a lâché.
Oussama, tu peux fermer le couvercle avec le bras. C'est parfait. C'est un joli coup.
So this was a big celebration at the Musée de la Mer, Marseille, where everyone wanted to attend and see this robot. But in the meantime, we pursued the work. We wanted to take our robot much deeper. We wanted to take the robot to thousands of meters. Going to thousands of meters is very challenging. It requires a lot of redesign and work, but we did it. And here is the new robot that is now tested at Stanford in the pool here. And hopefully soon we will be able to take this robot to the Mediterranean, where we have a number of expeditions. In fact, Bruno, this is going to be very close to Naples, the locations that we are considering. So hopefully sometime we can bring this robot to Italy as well. So here is the robot navigation using the haptic device. And the robot is interacting with divers. We are testing the hands. We developed 2 new hands with different number of fingers and more efficient grasp. And right now, these hands are being tested for different shape of control. We can locate and see the navigation through the stereo vision on the eyes of the robot. And this is very important when we are deep. We need to see the hands. There are a number of sensors. There is a chest camera that is locating the objects in front of the robot, but also the stereo is very important to find the depth. And here we are telling the robot to go and try to grasp this cup. And it is adjusting the hand, and it's managed to grasp it very quickly and hand it back to the diver, which is remarkable in those early tests of the robot. These are images that no one has seen yet, and I'm so pleased to be able to offer these different images to the Maker Faire for the first time. Here, the robot is interacting with a diver. I'm sorry, I can see the image is blurred. Hopefully it will come back. And now the robot is grasping this object. And finally, the robot is placing it back on the table. And it's still very shy from its performance that has to be completed. Thank you very much for your attention.
So thank you, Professor. Thank you for this wonderful story, wonderful images. I have to tell you a few things. The first one is, you know, my last name is Luna, it's Lune. So you were in my destiny today. My name is Riccardo Luna, like the vessel.
Wow.
So I had to be here today.
What a coincidence.
Yeah, what a coincidence, really. So the first very simple question is why your robots are human-like? So why they look like humans? It was necessary for some special reason, I imagine.
Yeah, this is a very, very good question. And the idea is this robot is your avatar for yourself. You are the diver, you are the archeologist. Archeologists are very keen about being able to touch themselves. So this is the robot that is replacing the diver. And this is the robot that is going to interact with other divers, assisting other divers. And essentially it needs two hands, it needs a head, it needs the eyes, it needs to be able to rotate. And that's why it comes to be very close to human form. Actually, it is not exactly a human, it's a mix of a human with a fish, because it doesn't have the legs.
So, Professor, a very complicated year is coming to an end. And what do you think we have learned as humanity from the pandemic?
Somehow I didn't hear you very well.
What do you think we have learned from this very complicated year as humanity?
Well, what we learn is that robots, as much as we want robots to be able to help human and be autonomous to do everything, we are realizing that robots can be functionally autonomous, but robots need cognitive support from human. And the connection between human and robot is critical, and the interface that brings visuals and touch, haptic interaction is amazing. And we are applying this in many other domains, in hospitals, in the workplace, and I see a lot of future development for the technology of connecting the human with the machine.
So, Professor, we have the same questions for all the guests of the Maker Faire. Which is your big dream for the next year?
Well, I'm just waiting for 2021 to be able to fly again and visit my friends in Europe and take our robot to the Mediterranean for this exciting expedition that might happen in the spring or depending on the situation,
save the date,
maybe later in summer.
Save the date. The next Maker Faire Rome is going to be in October. So in October, we are going to invite you, for sure. In Rome, next October, with the robot, hopefully. Okay,
I hope so.
We will find a big swimming pool.
It will be a great pleasure.
Okay, thank you so much. Good luck.
Merci, mon cher.
Thank you. Goodbye, everyone.
À bientôt. Ciao.